Welcome to E.D.S. Shandon again. We have another video for you that we're going to try to produce this week. What we've done is we have to cut down some hinges, and what it is they're called swing clear hinges, and they allow the door to swing in a way that it provides clear width in an opening, so that the door is not in the opening itself. And so the hinge looks similar to this. And what our problem is that the distance from here to here is 2 inches. And where the frame is set, it's in 1/4, and that door, the frame is set within the wall. So we only have 1.25 inches. We typically have a 2-inch face on our hollow metal frames. But in this case, we only have 1.25 inches. So what we have to do is we have to take and cut this down about 21-30 seconds, and then rejoin the piece together, re-weld it together. And so to do that, I've made a jig, because we have to make sure that these are cut just perfectly so they can mate back together again. And we made this jig. Unfortunately, the first run with this jig produced a little bit of a problem. As the parts ran out to the end, you can see here that this isn't cut. What happened is this got loose from the bracket holding it and was thrown aside. Okay, and so it never finished cutting the part. So we had shims, and I'll bring this forward. We have shims right here under each one of the knuckles, and then we have this bracket that's fastened down on top of the knuckle to keep it tight. But even with those shims and this bracket on top holding it tight, it still threw that part loose once it got to the end of the cut. So what our thought is now, instead of using shims in the back, I'm going to countersink this. I'm not countersink it, I'm going to drill and tap it for 1/4-20 screws. I'm going to put some 1/4-20 socket head, not socket head, but they're
Have you ever had a dream that you want
brain dead this as I typically are. I am when I'm in front of the camera. At any rate, we're going to put some adjustment screws in here that will adjust up. We're going to mount a bracket on this bracket that comes down on top of this, and then those set screws, that's what I was looking for. The set screws will come up and push it up against that bracket, and so making a firm connection so that as this cuts through, it can't throw that piece out of the bracket like it's currently doing. So hopefully that'll solve my problem. So that's what I'm going to do first, and before we start cutting. So I have to do that, and then I'll get back to you. Okay, so this is our refined hinge jig. I'm going to get a pointer so I can show you some of the points that, things that I've done to it. Number one, I've taken and I put set screws under each knuckle. This is the knuckle of the hinge, these three here. And there's a set screw under each one of them tightened up against the knuckle with this bar holding down on top of the knuckle. Then on this side, I've put a plate that's fastened to this upper bar that applies positive pressure down on the hinge itself. Because what's been happening is I finish my cut, it pops the knuckles out from underneath this. So hopefully this is going to prevent that. We're going to give it a shot and see how she works. So that's the idea to do so. And I've got some video of that on I had to mill this all out a little bit wider. I did have about a 1/2 inch space in there, but I milled this out deeper so that I could get something in here to tighten those set screws. So anyway, we're going to give it a shot, see how it works. Hopefully we'll have a nice even cut, and this will end my big problems with cutting these hinges. And I forgot to turn the camera on, but as you can see, I made my very first cut there. Went all the way through. The knuckle did not pop up out of there, so we're good. Made the end cut all the way through. I'm happy. We did what we wanted to achieve. Okay, so I'll show you how I set up these hinges. First of all, you take the hinge, put it in. We have 4 12/24 screws that we put into our jig holding the hinge in. Now I want to check the back and make sure that my pins are all the way up against the knuckle. And I'll just tighten them just a little bit. You can't get an Allen wrench in there, so you just have to kind of tighten them by hand. And unfortunately, these aren't precisely bent, so each knuckle is just slightly different. So you have to adjust every time that you put this in. So now the next thing that I do is we take our top down, and I'm going to take this and we're going to loosely put it in. Otherwise I won't be able to get the screws in afterwards, because it kind of sweeps down at an angle, so once it's tight. No, it's not wanting to go. Let me get my screw gun. We'll just must be some junk in there. I'll have to tap that out again. Oops, don't want it tight. Okay, now tighten these down. Let's just take it down snug. Then pat it on both sides a little bit. Make sure that I'm firm down on top of the knuckle. Now I'll tighten these up. And now she's ready to go into the vise. Okay, I hooked up this mister to my Bridgeport. So now we're going to go ahead and cut it. I was using a hand coolant, and now this is more automated, so we're going to go ahead and get it started. Okay, so I've got all my hinge parts cut. We did a practice weld here. This is the weld that we did. I've tested that weld and measured its penetration here. So the weld goes 0.85 of an inch through this part. So a little bit better than halfway. Well, actually, it's quite a bit more. It's 2/3 of the way, nearly, of the thickness of this part, which is 1/8 of an inch. And so I thought that that was sufficient for this part, but these are all 0.190, which is a little bit thicker. So I increased the amperage on my welder to 150. I had it at 130 when I did that weld, so I'll get a little bit more penetration on the thicker part that I have here. So here's the setup. We're using the Bridgeport, and we made a bracket that fastens up into a collet, and this part is contoured to fit the torch, and then you can see a little bit of the contour on the front, and then it's just strapped to the bracket. And so now I can use my spindle lever to raise and lower that as needed, and I can use my DRO. So I've got it raised above my part 1/8 of an inch. I don't know if you can see that. It's centered and right above that slit, about 1/8 of an inch. I've run the full lineal length of it to make sure that the torch won't hit any of the brackets that are holding it down. The part has been washed in acetone, so it's clean. We've got a ground right here on the vise. Some of you might be saying, what in the world is he doing with that? It's a magnetic ground. It doesn't seem to leave any scars on the vise, so I think we got good contact there. And in our practice welds, it didn't seem to cause any problems. And so then what we'll do is we've got our power feed already set. So with the last piece that we did, that 1/8 inch piece, I think that'll be the same speed that we'll feed it. We'll wire feed some stainless steel wire as we're welding, and this is on a high frequency start, so I don't have to touch the metal. I just have to press my foot pedal, which is right down here, to get started, get my puddle going and move across. So the reason I did it this way is I'm not a TIG welder. This is the first time I've ever really TIG welded. I've tried practice TIG welding on a few little things here and there, but I am not a TIG welder by any means. Most of what I've done is on the MIG or on the stick. So so this is a new experience for me. This is very, very important that this is done correctly. And so I don't think I have a steady enough hand or a good enough eye to do this work. So I decided to basically make this more of a mechanical process than an eye and hand process. And hopefully that will avoid any errors, and I'll get a very nice product when I'm done, when I'm completed. So that's the idea. We're going to be using the Bridgeport mill to actually do TIG welding. I know I'm going to get all sorts of flack on that, but I found that I think that's going to work. The main thing that you want to make sure is, and again, you want to have your ground right here. You don't want any stray frequency or voltage or whatever you want to call it, amperage, going through your electronics, because it'll just totally mess them up. So that's one thing that you want to be careful of, and so I've got that grounded right there where the hinge is, so that I don't, hopefully I won't get any damage to any of my devices. In fact, I'll probably turn this off before I start. I just use this to, I'll turn it off and unplug it. It's plugged into a completely different circuit than the Bridgeport. I have to leave this part on if I'm going to power feed. So we'll see how it goes. So far with my sample part, this is, like I said, this is just 1/8 inch steel, stainless, and it put a really nice bead on it. You can see that bead through there, a very pretty little bead. And like I said, I got penetration pretty near 2/3 of the way through, and we will be welding the parts on both sides. So I've got all these hinges to get welded up, and I might as well get started. Okay, we're going to start our weld. This is what our weld looked like on top there. pretty even all the way across. That'll be easy to clean up. I'll have to touch up the corners a little bit. Other than that, that turned out pretty nice. I'm liking it. I started out with standard TIG welding with 150, and I found that was too hot. So I took it down to 135, and that didn't penetrate quite enough. So what I decided to do is try pulse welding, and that's what I'm setting to now. I've got it set at 150 high, 75 low. I've got it, what is it, how many hertz do I have here? Well, this is my pulse time on is 50. My frequency, let's see, I need to get my frequency up there. Oh, there it is. 25. And my down or base pulse is 75. There we go. So anyway, so that's what I'm doing here with this event. So oops, take it back to my program. There we go. So that seems to be working better. So we'll take you back over and we'll begin a weld. So we'll start with a tack here on this end, in the center and this end, and then we'll come back and do a full weld. So this is our setup for welding the inside corner, this corner here of the hinge. We've got a dowel, a metal dowel running through the hinge, and then a clamp is clamping it to the block. So this is the block we've used for all the other setups. We've got an 1/8 inch shim on the back to hold this in place. So this is nice and firm. So we'll start our weld, bring it up to about halfway, move our clamp to the back, and then finish the weld. I was trying to find some smaller profile clamps that I could leave in place, but I don't have anything that will work to hold this in place without stopping and redoing it. So anyway, that's my setup, and so we'll weld all the inside corners, and then it'll be to grinding and what have you. You've seen the welding before, so we won't bother you with that.